How do we solve for p? P minus 3 to the power of 4 equal to 7 to the power of 4. This left hand side could be written as p minus 3 all squared times 2 equal to 7 to the power of 4 could be written as 7 squared times 2. This implies that. Now, let's move this guy to the left hand side. So that will be p minus 3 all squared times 2 minus 7 squared times 2 equal to 0. Recall that a squared minus b squared is equal to a plus b times a minus b. Take note of this identity. What we are going to do now is to apply this identity on this guy. By comparing, you will see that b minus 3 all square is a, while 7 square is simply b. So from this line, we're gonna have p minus 3 all squared plus b, that is 7 squared, times a, that is p minus 3 all squared minus b, that is 7 squared, equal to 0. This implies that, open bracket, if you expand p minus 3 all squared very well, you're gonna have p squared minus 6p plus 9 plus, what is 7 squared? 7 times 7, 49, times, if you expand this also very well, you have the same thing as this, p squared minus 6p plus 9 minus, what is 7 squared? That is 49, equal to 0. Let's proceed further. So we have p squared minus 6p plus 9 plus 49, that is 58, times p squared minus 6p, 9 minus 49, that is minus 40, equal to 0. This means that p squared minus 6p plus 58 is equal to 0, or p squared minus 6p minus 40 is equal to 0. Now, let us solve this quadratic equation, and later we are going to solve the second quadratic equation. You will see that we can only solve this using a quadratic formula, which is p equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. From this equation, a is equals to 1, b is negative 6, c is equals to 58. So plugging these values into this right hand side, we're gonna have p equal to minus into minus 6 plus or minus square root of b squared, that will be minus 6 all squared, minus 4, a is 1, c is 58, into 1 into 58, everything divided by 2 into 1. p equal to minus times minus 6, that is 6, plus or minus square root of minus 6 all squared, that is 36, minus 4 times 1 times 58, that is 232, divided by 2 times 1, that is simply 2. So we have p equal to 6 plus or minus square root of 36 minus 232, that is negative 196, divided by 2. p equal to 6 plus or minus, we can rewrite this guy as square root of 196 times square root of negative 1 divided by 2. Let's proceed further. P equal to 6 plus or minus, what is square root of 196? That is 14 times square root of negative 1. But we know that from the complex number, square root of negative 1 is equals to I. So we have I here divided by 2. P equal to, I can factor out 2 from this numerator. So I have 2 into 3 plus or minus 7i divided by 2. P is now equal to, clearly 2 cancels 2. We are left with 3 plus or minus 7i. This implies that P is equal to 3 plus 7i, or P is equal to 3 minus 7i. Let's call this P1 and this P2. Now, back to the second quadratic equation. If you look at this equation very well, it is factorizable. Yes. So let's factorize it. So we have P squared minus 6P could be written as minus 10P plus 4P minus 40 equal to 0. Let's separate this. What is common here? P is common. I can factor it out. So I have P into P minus 10 plus, I can also factor out 4 from these two guys. So that will be 4 into P minus 10 equal to 0. This implies that P minus 10 is common. So we have P minus 10 times P plus 4 equal to 0. This means that P minus 10 is equal to 0, or P plus 4 is equal to 0. Clearly from this line, P is equals to 10, or from this, P is equals to negative 4. Let's call this P3 and let's call this P4. You will observe that we have two complex solutions, which are this, and two real solutions.